So welcome to this webinar series on the chemical strategy for sustainability. We're going to talk about putting the chemical strategy for sustainability into action and looking closely at the challenges and opportunities for food contact materials. This is the first part of a four-part webinar series. We're going to have the next sessions in the subsequent months, so please keep an eye out on the FPF website for more information on the content and on how to register for these events. I would like to point out that we are recording this webinar today and we intend to make it publicly available on our website shortly after the webinar is finished. Some housekeeping rules, please. You can rename yourselves in Zoom. We encourage you to use the naming convention using your first name and your last name. We also have muted all microphones and video cameras of people who are not speaking in the first part of the webinar. But after we finished with the presentations, after our second presentation, we invite you to join a question and discussion session. And there, if you would like to ask a question, you can use the raise hand function in Zoom. And when your name is called out to ask the question or make your comment, you can please unmute yourself and turn on your camera so we can have a more realistic discussion here. Today we are going to set the scene. We're going to give you a background on chemicals, sustainable chemistry, hazardous chemicals, kind of the basis or the rationale for the chemical strategy for sustainability. Our speakers today are Professor Martin Scheringer, who will speak about hazardous chemicals and give us an overview and focus on how the CSS addresses the issue. And we also have Professor Terry Collins with us, who will give us a background on safe and sustainable chemistry, history and recommendations for implementing the CSS. And CSS, of course, being the acronym for Chemical Strategy for Sustainability, which is a mouthful to say. So what is the chemical strategy for sustainability? Just really briefly, this is a strategy that the European Commission published in October 2020, so half a year ago. And within the strategy, goals are set for many different aspects of chemicals management. And one of the important things that I want to point out here right now is that the specifics for how these goals will be reached, many of them still need to be defined. So this is actually work in progress right now. So for example, the criteria for safe and sustainable by design chemicals. This is something that's ongoing, defining what is essential use and so on. So this is very much work in progress right now. And that's also a reason why we think that our webinar series addressing the topic is very timely, because it provides a bit of background also for people who may be new to the whole chemicals issue. So if you want to know more about the chemical strategy for sustainability, then please do have a look on this link. I will try and put a link in the chat in a moment. Sorry, it's difficult doing the multitasking. And we also had an excellent presentation by Dr. Xenia Trier from the European Environment Agency, who spoke at our Food Packaging Forum workshop last year in October, really just a week after the Chemical Strategy for Sustainability was published. And to put it into context for everyone, what its relevance is for food contact materials. So this is also a presentation that I would strongly recommend for you if you would like to have a bit of a more detailed understanding of the strategy. And with that, I would like to just real quickly, I'll do that later, hand over to our first speaker, which is Professor Martin Scheringer. Good, and your camera is on. Excellent. Martin, you are the president of Food Packaging Forum, but you carry many other hats as well. You're a professor at Masaryk University in Brno in the Czech Republic and at ETH Zürich in Switzerland. And I think you will also introduce yourself a little bit more. So over to you, Martin, please.
Yep, thank you, Jane, and welcome also from my side to everyone here to the first webinar of this FPF webinar series. And I will just share my screen and show my slides. And I'm going to speak about hazardous chemicals, an overview, and focus on how the CSS addresses the issue. And as Jane already said, I have different hats in a way, and I'm a chemist by training, and I share my time between two positions. I'm a professor of environmental chemistry at the Masaryk University in Brno in the Czech Republic, and I'm a senior scientist and group leader at the Swiss Federal Institute of Technology, ETH, in Zurich in Switzerland. And I'm also the president of the board of the Food Packaging Forum Foundation. Now, regarding hazardous chemicals, when we start from all the chemicals that we use in our society, we will see that there are many, many of them. We use them because they provide many benefits in different ways, and that's the main reason why we have to talk about also the other aspects of properties of chemicals, because they're also useful in many ways. Then there are so many, which also means that for the same purpose, often there are also several alternatives. So there are several chemicals that have similar properties or similar function, and that's important to keep in mind because we may want to replace a particular chemical with other ones, and then we have to know, we have to be aware that there may be possibilities to do this because we have a choice. Another aspect of the many chemicals, what we can see just from the number, is that they span a wide range of properties. Properties, for example, solubility in water, or vapor pressure, or density, and also some properties that are hazardous, for example, flammability or toxicity. So there is this wide range of properties, and some chemicals are more hazardous than others. And that's why we want to talk about this and find out how we can identify the more hazardous ones and also how we can avoid them. That's mainly one of the big goals of the chemicals strategy for sustainability, to avoid more of the hazardous chemicals that are still in use. Before we look at what the CSS wants to do, I would like to speak a bit about hazard, exposure, and risk, just to clarify what these terms really mean in our context. And as I just said, hazard is really a property of the chemical. We may call this inherent properties or chemical-specific properties, such as the toxicity of a substance, or the flammability, or the carcinogenicity. And these properties are independent of how a chemical is used and where it is used and who is using it and all this. This is really, they are carried by the chemical. And as I just said, there is a wide range of properties, and some of them have been officially acknowledged as hazardous properties also under the chemicals regulation of the EU. And some of them are listed here. For example, carcinogenicity, mutagenicity, and toxicity for reproduction. These are the so-called CMR properties, or the combination of persistence, bioaccumulation, and toxicity, the PBT properties. And currently under discussion is also the combination of persistence, mobility, and toxicity, which is then the PMT substances. So you see, there are these sets of hazardous properties that would define what a chemical of concern is or a harmful chemical. And then there is this idea that ideally we would be using inherently safe chemicals wherever we can. This is chemicals with no hazardous properties or where the hazards are not strong. That is the ideal, and I think the CSS is intended to make a step towards this ideal. Then, in addition to hazards, there's also exposure. Exposure is, in a way, the counterpart, because this is exactly about where the chemical is used and who is using it and how much of the chemical is used and is also then released, perhaps. So exposure means that a chemical is present in the environment of an organism, be it the outdoor environment or the indoor environment, or it can also be within the tissue of an organism. Then we call this internal exposure. And it is measured or quantified as a concentration level of a chemical in water or food or air or in blood. And then risk is the combination of hazard and exposure. Risk is then what may actually happen in a way, because a chemical may have a hazard, but if there's no exposure, then there's no risk. Or if the hazard is weak or is not there, then even a high exposure may not be risky. And that in general makes sense and is a good concept. But we have seen from experience over the last more than 20 or 30 years even, that a thorough risk assessment of a chemical that is used in many ways in large amounts in our current society, that such a risk assessment requires many data of different types. It involves also many uncertainties because these data may be uncertain or difficult to measure, or they may be missing. And taken together, all of this takes a lot of time. And often then the conclusive results of a risk assessment only come after years of further investigations. And therefore, it's also something that we have learned in a way. There is this danger of paralysis by analysis in the course of a detailed risk assessment. And there's also the danger of taking absence of evidence, no data, uncertain data, lack of data, taking this as evidence of absence and concluding that the risk is low. I don't want to talk about these problems of risk assessment now in more detail. We may come back to that in the discussion later on, but then would now like to move on to the chemical strategy for sustainability. Here is the overview page as it is provided by the EU, and you can find already a good overview of the main goals of the CSS from this page here. I want to pick out just select some aspects of it that are particularly interesting in our context. And I think a key point really is that the CSS has this strong focus on hazards of chemicals. This is really new and it's important. It's new because it's a stronger focus on hazards compared to the existing regulation of chemicals in the EU. And hazards is really what makes chemicals difficult to handle. And also for consumers, of course, it is kind of logical that they should not have hazardous chemicals in products that they have in their hands or on their skin. And therefore, it is important and useful that the CSS addresses this problem of chemical hazards. And the second point that's really strong and important and new is that the CSS adopts the concept of essential uses. Because this concept, and I will explain what it is on the next slides, this concept opens a pathway for a more efficient, but still targeted phase out of chemicals of concern. More efficient compared to a risk assessment that may take years and years and years, for example. So these are the two aspects I will highlight as particularly important and novel. And I will now say a few more words about the concept of essential use, because this is driving a lot of the current discussion, also in or under the CSS. Initially, the concept of essential use was introduced under the Montreal Protocol on ozone depleting substances already in the 1980s. And then it was recently again proposed also for other chemicals of concern, not just the ozone depleting substances. And this is the paper that where I also was involved personally with a group of colleagues who have published this paper 2 years ago, where we proposed that the concept of essential use can also be applied to PFAS, perfluoroalkyl substances, and to determine under what conditions they may be phased out. What the concept actually says is that it includes or contains two elements. The first is that the use of a chemical is necessary for health, safety, or is critical for the functioning of society. And the second element is there are no available technically and economically feasible alternatives to the chemical. Of course, this is quite general, but still it gives a good orientation. And as Jane said at the beginning, specific criteria, what this actually means in the context of specific chemicals, still have to be developed. A very important point, however, is that this is really about essential uses, not essential chemicals. This has sometimes been used or said, this term, essential chemicals, but that is a fundamental misunderstanding. We use chemicals because of the value in use, of the function, of the features, of the properties they have. We don't use them per se, and therefore there is no such thing as an essential chemical. That's important to keep in mind. So in the CSS, the concept of essential use is mentioned at the highest level for two aspects at least. And this is first that it should be applied to harmful chemicals in consumer products, which makes a lot of sense. And these are many different chemicals. And I think Terry will also talk about some of them in the second presentation in the webinar today. And I think it makes perfect sense that consumer products should not contain harmful chemicals, because consumers often don't know and cannot even know what the chemicals exactly are and what may happen if a product is used in a way that is not intended. But still, I think that's an important goal where it makes perfect sense to apply this concept and try to get rid of many of the harmful chemicals that are still present in consumer products. Second, the CSS mentions that for PFAS in particular, this concept of essential use should be applied. PFAS are perfluoroalkyl substances, or poly and perfluoroalkyl substances, and they are a big topic in itself and more than we can even discuss here. The main problem is that they are so extremely stable and persistent that they don't go away, and therefore they accumulate in the environment and in humans, and this is a big source of concern. And that's why the CSS singles out PFAS as a group and mentions explicitly that the essential use concept should be applied to in order to guide the phase out of as many PFAS as possible. And this article by Sharon Lerner in The Intercept here that I have on the slide is a very useful overview of many uses of PFAS and also of the problem caused by these chemicals. Then there are, of course, many other areas in the chemicals strategy for sustainability. I just give a quick list here of an important topic is chemical mixtures, the so-called cocktail effect, because obviously people are not exposed to a single chemical alone, but they are exposed to many chemicals in combination. That also needs to be better addressed. Then the CSS highlights endocrine disrupting chemicals. It calls for better hazard identification for these substances and for better information about them. And then in the end, it also calls for a phase out of endocrine disrupting chemicals wherever possible. It also talks about the safe and sustainable by design concept. And of course, it also mentions the circular economy. And this is my last slide that I would like to share here about the circular economy, because here again, we have the problem of hazardous chemicals that when they are present in materials, in plastics, and there is recycling, which is the goal of the circular economy, then these chemicals also go around and they contaminate goods, new goods made from recycled materials. And that, of course, really undermines the idea, the basic idea of the circular economy. And that is nicely also describes this problem in this article here by Klaus Kümmerer, James Clark, and Vanya Zuin. And they really say basically that the chemical industry would have to be redesigned if the type of products that it makes are meant to be suitable for the circular economy. So it's a fundamental statement, and it has huge implications, I think, for the chemical industry in the future. And with this, I'm at the end, and I would like to thank you for your attention.
Wonderful. Thank you so much, Martin, for that excellent overview. And thank you also for staying on time. Makes my job easy. You mentioned the chemical industry needs to reinvent itself. And I think that's a perfect segue to the next topic. We are in the very capable hands of someone who knows the chemical industry by heart, who's been part of the chemical enterprise for decades and is one of the pioneers of green chemistry. Professor Terry Collins. Terry, I give the floor over to you.
Thank you very much, Jane. I'm sorry I pressed the button a little early there.
No worries. Let me just add one last thing as you're getting ready. Terry is also on the board of the Food Packaging Forum Scientific Advisory Board. So, and with that, over to you, Terry. Thank you for being here today.
Thank you so much, Jane. And thank you so much, Martin, for that wonderful introductory talk. You know, I'm inspired by the fact that the European Union is going to take safe and sustainable chemistry seriously. And what I hope to do in this talk is give you some warnings about things that can go wrong. So I'm one of the original green chemists. I was wildly enthusiastic about the field for about a decade, but I really think ultimately the performance of green chemistry has been very disappointing. And I'm going to try to tell you why that's the case, in the hope that I may give you some information that is useful in avoiding the same fate that green chemistry has fallen into. So I really like, was one of my heroes, David Orr. He's at Oberlin College. And I think he really gets it right with this. The problem of education. Education is not widely regarded as a problem, although the lack of it is. The conventional wisdom holds that all education is good, and the more that one has, the better. The truth is that without significant precautions, education can equip people merely to be more effective vandals of the earth. If one listens carefully, it may even be possible to hear the creation groans every year in late May, when another batch of smart, degree-holding, but ecologically illiterate Homo sapiens who are eager to succeed are launched into the biosphere. That's from 1994, Earth and Mind. And I also like this cartoon by Walt Kelly from 1971. It's fairly famous. We have met the enemy and he is us. And so if you just look at what the two characters there are looking at, all strewn throughout their local environment, nearly everything there is to some extent, if not completely, chemically based. Chemical contamination of the ecosphere is really destroying it. And Martin mentioned, and the European Union is focusing on endocrine disruption. Endocrine disruption is the best understood mechanism or suite of mechanisms for low dose adverse effects. Low dose, and if doing animal studies, low concentration, if you're working with aquatic life. So low DAS or low CAS. The low dose adverse effects, where endocrine disruption mechanisms are the things we know most about, of certain everyday, everywhere chemicals. We're talking about some of the biggest chemicals in production today that are endocrine disruptors, represent the biggest threat of the chemical enterprise to sustainability. And if we're going to, we are not going to, the European Union is not going to have a sustainable chemical industry if it does not deal very effectively with endocrine disruption. Pete Myers will come along in a later one of these series to tell you about that. Pete, of course, is a co-author of Our Stolen Future. And this book, after I read it, really changed my life. In about 1997, I think I read it. It changed it forever because it's very convincing that chemicals in exquisitely low concentrations can wreck living organisms. I predicted in 2000 from the reading I did based on that, that if we did not deal with low DAS quickly, that we could well be sterile in the foreseeable future. And in the meantime, the studies of Western man, this is, conducted by Shana Swan, where this article, Sperm Count Zero, is a very easy read, available online, will tell you that from 1972 till 2011, we lost more than 50% of sperm count. The median sperm count fell by more than 50%. And if you project that line out at 24, you reach the median sperm count reaches 0 in 2045. That means half of the young males in 2045 will have no sperm. The remaining males will have will almost all be in serious trouble, either infertile or subfertile. Shana's book came out on the 23rd of February, Countdown. It's a brilliant book. I recommend it to everybody. The biggest books that have affected me are Silent Spring, Our Stolen Future, and now Countdown. I put those at the top. We did a webinar on Countdown with Shana in Pittsburgh. There is the website for it. There are many webinars. They're all really good. But I challenge you, anybody in this audience, to look at that webinar and think to yourself that we don't have to act immediately on endocrine disruptors. So green chemistry 30 years ago really looked like, wow, this was going to come along and make such a big difference. This is its definition. Green chemistry is the design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. It's a really good definition. It's about design against hazards. And that's really, if you look at the CSS, what the European Union is endeavoring to achieve. And then we get the 12 principles of green chemistry by Anastas and Warner, which for many years I supported, and I don't support them at all anymore, because what they do is they drag the field of chemistry down inside itself. You have important principles like designing safer chemicals mixed in with things, reduced derivatives or design for degradation or real-time, basically safer solvents. It drags you directly into synthetic chemistry, and it also makes it look like the chemists can handle this problem. They can't. We cannot handle, the chemists cannot handle, and the European Union must really get this very clearly. If you turn the responsibility of building green chemistry or safe and sustainable chemistry, as you're calling it, over to the chemists, they will fail. I actually had the first, produced the first principles of green chemistry. I decided to forget them when Anastas and Warner published their principles, but I'm now reasserting them. And that first one is that you have to keep it simple to tell people what the heck a field is about. Green chemistry, now safe and sustainable chemistry, if you like, aims to protect life. It needs to be interdisciplinary to be successful. How can you possibly design against a hazard if you don't understand it? And chemists are not taught about toxicity or ecotoxicity. They literally do not have the background needed to understand hazards. And here's another thing, which is, it is actually a principle because it's so important. Because of the immense complexity, if funders want green chemistry to succeed, they'll have to back a significant section of the field in the long term. So I knew that in the mid-90s, that, oh my God, this field was going to be really difficult to fund because everybody's running around trying on paper mills down in their specializations, and they don't have the time to come out and learn about other fields. And so this has been a tremendous burden. I have made myself quite multidisciplinary, but I have had to basically finesse the funding system. I've managed to do that. I'm very lucky. We're in good shape funding-wise, and we always have been. But boy, what a job. So that was published in 1997. The chemical, low-dose adverse effects make the chemical enterprise categorically unsustainable. The sperm count reduction, I believe, is in the vast majority due to chemicals. I will argue that with anybody who wants to at the end of this. It's not lifestyle factors, it's mostly chemicals. Our handling of many low-dose today highlights our personal, institutional, and civilizational inadequacies. The civilization in all its pockets, pretty much across the board, is doing a miserable job of dealing with these very threatening toxicities. The scientific basis and facts of low-dose threats are undeniable. Some of them are fast-acting, some of those, such as those that are knocking about sperm counts and sperm quality. And really, honestly, academic, industrial, and regulatory chemistry all need reality checks and much change to deal properly with low-dose. I wrote about this in 2003. This is the first time any chemists did say publicly that you know, we really need to get toxicity education and ecotoxicity education into chemical research. And I've basically done that by myself at Carnegie Mellon. There's a lot of talk about it, but the action is completely disappointing. The thing that you've got to do if you want to avoid a low DAF chemical is you've got to know that it's a low DAF chemical. And that means you've got to be able to do the right tests, the right assays to identify that. And if you go back to, say, 2008, we didn't really know how to do this. And we put together a team. In fact, I didn't. This guy here, Pete Myers, really put together the team. He's the, as I call him, the conductor of the Endocrine Disruption Orchestra. Many of the members of the orchestra are right here. And then different of these people bring their very special expertise to bear. And this group of people works together amazingly well. It is the most fabulous privilege of my professional life to be to count them as friends and colleagues. And so you've got Mr. Sage, Mr. Pediatrics, Mr. Thyroid, Mr. Sage, Mr. BPA, Mr. Funds. That's Jerry Heindel, who really led the funding from NHS for many years. And we sat down over about 5 years to try to figure out how do you determine if you've got an endocrine disruptor. And then we published this article in Green Chemistry, and I recommend it to the European Union. I actually think you're reading it because the tests we're seeing pop up that you are hoping to use tests that are highly recommended in general in this article. So can chemistry become sustainable? Perhaps, but it isn't unless we focus on 5 performances. This is language we've developed at Carnegie Mellon of equal importance, and make them of equal importance to the value proposition. So if you have a chemical technology and it's not, say, a drug or a pesticide, but pretty much everything else, it gets into the market because it has high technical performance and high cost performance. But every chemical has a health performance, every chemical has an environmental performance, and every chemical has a fairness performance. We just have very naively said to ourselves, wow, if this chemical goes in and does this cool thing, it's going to be a good little chemical and just do that cool thing and do nothing else. And that is just hopelessly naive. And really, it's been obviously hopelessly naive for decades, way back to Silent Spring, in fact. So the question for sustainability is, can you generate wealth because a chemical technology performs well, while knowing to the highest standards of contemporary science that no adverse effects impact human health or environmental welfare, while the technology is universally fair? Fairness performance is a little bit harder to see, but you sure know it when you see it. I won't go in for lack of time. And so this is going to require multiple assets. Number one, we have to have regulatory tools. And honestly, if we just look at Dark Waters, which is about DuPont's really predatory behavior on the city of Parkersburg, West Virginia, just look at that and wonder to yourself how that kind of stuff, that movie, Dark Waters, how the content of that can possibly continue going on. Yet I know that it's going on with multiple chemicals around the world. We have to not only have regulatory tools, we have to have legal tools. People have to suffer if they're going to make decisions knowingly that hurt people. Green design strategies are critical for developing health and environmental performance, new chemical products and processes. So we really have to think about what the heck green is. And honestly, if you prove that you don't have low DAFs with a chemical, I think you're 95% of the way there. And then you need stewardship tools. We are going to need to continue to use some endocrine disrupting chemicals, and what you need is stewardship tools to make sure they don't impact health and the environment after use. So finally, some tough questions. Will the EU CSS follow through in dealing with it? Will the EU have a large budget for studying marketplace chemicals for low DAFs and low CAFs? What will the EU do when it knows a valuable commercial chemical is eliciting low DAFs and low CAFs? Will you have the courage to get rid of it? How will the EU treat an academic who claims that a chemical should be removed from commerce because it elicits low DAFs or low CAFs? Will that person be a hero or heroine, or will they be ignored, or will they be defunded? Is the EU better than being part of our failing civilization that cannot even protect its reproductive capacities of its people, because we have all become so seduced by chemical products and processes, including those that elicit low DAFs and low CAFs? Moving forward into the future, the EU's ability to formulate correct answers to these questions will determine, just for starters, the reproductive vitality of European youth. Thank you. I'll finish at that and stop sharing my screen.
Wonderful, Terry. Thank you so much. And thank you also for staying right on time. You make my job easy today. Okay. I think that's given me at least quite a lot of food for thought. I don't know about you. I will now enable participant unmuting and starting video. And if you would like to ask a question, please use the raise hand function in Zoom. If you have trouble to activate that, then you can also use the chat. You can just type something in the chat, but there's a lot of people here and my screen is not so big, so I can't see if you have your hand up physically. So maybe we can start with what you were saying about, Martin, about that not chemicals are essential, but products. I think that's a really important distinction, and I think your presentation was very clear, but I would just like to go back to that real quickly while people are still formulating their questions and comments. What can you say about that? Do you have examples?
I mean, there would be many examples, I think. It is just that the reason why we use chemicals, make and use chemicals, is not because we want, and some chemists love chemicals per se, including perhaps myself. I have always been fascinated by the substance in the flask or something, but most people are not. So why we make and use chemicals is because of their performance, of the function they have. And that's what we care about. And that's what may also be so important that we'll call it essential, because it's really a function that saves lives and is really, yeah, very, very helpful, and not just for convenience. So it is about the function that the chemicals have, but not about the chemical substance as such. And if we can find a way to fulfill the same function with other chemicals, then that's also good. Or if we can find a way to change the overall situation in such a way that the function is no longer needed in the same way, then this is also good. Mm-hmm. So I think we should keep in mind that it is not about chemicals per se. They are fascinating to chemists, but they are not the real purpose of, yeah, they're not an end in themselves. That's what I want to say.
Yeah, thank you very much for that clarification. I think it's important because, you know, one easy way could be to say, well, what about pesticides? Pesticides are, well, it's not one single chemical, but it's a fairly discrete mixture of a few chemicals or pharmaceuticals. And it's not the product, it's about the function. What's the purpose? Why do we take one chemical substance, aspirin, for example? And we really need to look at the function. So it's taking a step back and sort of opening the system a little bit. Okay, I see people are a bit shy here, or maybe your raise hand function doesn't work, but people are putting questions in the chat. Mike Neal. Mike, do you want to unmute yourself and ask your question live? It's a bit of a provocative question, I would say. Go ahead, we like questions.
I have done, but I have to tell you, I've got a very, very unstable internet connection, so I might just be, no, it just occurred to me that, you know, the major problem that we have in the world, end of story, and it's the worst of the whole lot, is our population explosion. We need our politicians to stand up and say something about reducing a population. They'll never do it because they'll get voted out. But see, somebody's replied to me anyway, but I'm just saying, is if we're having a falling sperm count, that's going to deal with the population growth anyway. Just a thought for somebody to think about.
Yeah, well, I don't know, Martin, Pete, Terry, sorry, would you like to respond to that?
Well, so I do not think that any corporation or set of corporations should have the right to take away from human beings their ability to reproduce. And yes, we have a population problem, but it really very much depends on where you look. So for example, if you look at Singapore, its current citizen birth rate is just over 50% of what's required to maintain its population. My guess is with the enormous chemical facilities at Jurong Island in Singapore and the enormous amount of chemical products and processes in the Singaporean economy, that they're really in quite an advanced state of reproductive decline. They haven't tested themselves properly yet. The good data is in Europe, North America, and Australia, New Zealand, which is why we talk about Western demand. So that's I don't think chemical companies should get a pass on that.
Mm. Okay, thanks, Terry. It's great. Lots of questions are popping in. I see Fabrice and Peter have their hands up. I still have 2 questions that came in from the chat first, so I'm going to take those first. So Martin, here's a question for you from Christina. If recycled plastics are a source of dangerous substances, do you think that we should rethink this issue and invest in chemical recycling to get cleaner plastics?
I think yes, basically yes. Of course, we may also have to redesign the composition of the plastics, and we may also have to reduce the amount of plastic that's used. I mean, Terry showed the curves of plastic production increasing and sperm count decreasing. So I think it's not just about the type of plastic and the way we make it. It's also about where it is used and how much it is. But of course, we need to invest into this and think about how we design materials. And we also have said this many times at the Fpf workshops that many materials are just too complex, and they're kind of beyond the point of where they can be easily handled and recycled. They may have to be redesigned, even not from scratch, but from an earlier point.
So just a quick follow-up question or comment. So maybe we need to also have a discussion about essential uses for plastics.
Yeah.
Okay, next question from Eva Kumar. How will the essential use concept be integrated into EU legislation? What kind of time frame is being targeted? I think, Eva, we can quickly say we don't know.
Exactly. This is, of course, a big question, but exactly. And I'm a scientist who thinks about the concept and aims to develop the concept, but I don't know the answer to this question.
Okay, great, thanks. So let's turn to Fabrice. Fabrice, do you want to unmute yourself? Turn on your camera, please.
Yes, thank you. Thank you very much, Jane. I will not turn the camera because my internet is also very unstable, so sometimes I'm losing you. I hope you can hear me.
Yes.
Okay. No, I had a basic question. I should know the answer to that, but I'm still struggling, and I'm not sure that you can help me. But we have in the EU one of the most advanced chemical legislation, which is called REACH. And I was just wondering why we need a new piece of legislation. Why do we need to add another piece of legislation? Why is REACH not able to tackle those issues? Do you have any views on that?
Great, thanks, Fabrice. Who wants to take that? Martin?
Yeah, I have a quick first response. And I mean, I agree this is a complex question, and I don't have the full answer. And I think the question is a good one. But what I would, as I try to also say in my presentation, I think REACH has not yet enough focus or emphasis on hazards, but and we have to try to get rid of hazardous chemicals in many applications. That is one part of the answer, I would say.
I would agree with Martin. The European Union has not been up to now doing the right kind of testing of chemicals to detect low dose adverse effects. As a consequence, you're right in there with the sperm count decline that's going on. I think you really, what I'm most hopeful for is that the European Union will come to lead the world in demanding the kind of assays we need to detect endocrine disruptors and other chemicals that produce these effects.
Great, thanks. And maybe just to add, Fabrice, the chemical strategy for sustainability is not regulation, right? It's a strategy that will be implemented into regulation. So that's something that we need to see. It will affect REACH, also food contact regulation and so on. Great. Peter, please, you can unmute yourself, please. Oh, I cannot hear you, Peter. I can see that you are unmuted.
I have to, can you hear me now?
Yes.
Right, I hope it's a good question after the delay. I have to declare a business interest. I really am investing my thoughts and time into the topic of designing non-hazardous substances. And this is a stated objective within the chemical strategy, and of course the stated objectives of many NGOs. But I'd like to ask Martin and Terry an honest question. Is this actually achievable, that we can get to a toxic-free set of substances available to do all those very important functions? Is it just a dream, or is it achievable?
Terry?
I'd be interested in their comments.
I think the answer is yes. First of all, we have a large number of chemicals that, to the best of our knowledge, are not endocrine disruptors or do not elicit low-dose adverse effects. And so the answer, I believe the answer is yes. Unfortunately, the whole landscape is polarized by the fact that some of the biggest, I will mention BPA and polycarbonate plastic. I will mention phthalates, which are typically anti-androgens, i.e. they have these effects on male reproductive health. And unfortunately, we have a large number of these things. I'll mention PVC, because if you burn it, you make dioxins. And some of the dioxin family are so potent in terms of reducing sperm counts that they're just shocking. And so if we put in PVC all around the world, every time you have a big fire, you have to conclude you're going to have dioxins everywhere. So I worry about the states of Victoria and New South Wales and Australia after those big fires, because a lot of buildings were burned that would for sure have had PVC, and therefore one can conclude that that countryside is pretty contaminated with dioxins. But on and on one can go. And this polarizes everything, because quite literally, we're not going to get there if we don't. We have to look forward to have safe chemicals in the future. I think we can do that by doing appropriate testing. But we cannot not look back, because I will tell you, if we don't make another single chemical, we're still going to be sterile in 2045 because of what we've already got. So there is no escape for our, we're talking about our species, and we're talking about every other living thing with an endocrine system. There is no escape unless we find the courage to deal with the meaning of this data. Unfortunately, it's been resisted ferociously by industry for decades. And so we've got this enormous handicap of not being able to do the right thing at the right time when we learned about it. And so there is a lot of change that has to occur. And if we want to keep burying our heads in the sand as ostriches, we're going to go the way of all flesh.
Martin, do you want to add something to that?
Not really, not much. I agree, and I would say, as I also had it in the presentation, it's a goal, and we can make steps toward that goal. And the CSS certainly, I think, is a good step, or is it an attempt to make such a step? And we should go as far as we can.
Thank you both.
Thank you, Peter, for that good question. I'm just going to read a real quick question here in the chat from Alfred Dratva, who's asking how to deal with cocktail effects in real. Seems to be a nearly hopeless exercise. We are going to dedicate the next session of this webinar series to looking at chemical mixtures. So we have Professor Thomas Backhaus, who's an expert on chemical mixtures, and hopefully he can help us see the light at the end of that tunnel. Then I encourage you to raise your hand. I'm also just going to read more questions that came in through the chat. So from Marcin Achinsky, when virgin plastics are free from hazardous chemicals, then consequently recycled plastics will be too. Does one of you want to comment on that?
Do you want to go? Do you want to go first, Martin?
Yeah. I mean, that's yes. It's a complex one because virgin plastics is never, I mean, it's called virgin, but of course it's never perfectly clean, for many reasons of remaining monomers or oligomers or other substances that are created in the polymerization process. So even virgin plastic is not perfectly clean, and there has been a lot of discussion about this issue just recently, also in the context of fluoropolymers. So, but of course, the cleaner it is, the better. But again, I think we have to think about where it is used and how we can reduce the amounts, and not just try to make it cleaner.
So most of the additives, or many of the additives that we put in plastics are serious endocrine disruptors. And so that's got to stop. Often the problem, the problems come in two kinds. So if it's polycarbonate, i.e. polymerized BPA, the actual monomer and the actual material is a problem because so much polycarbonate finds its way into landfills, where, of course, carbonates hydrolyze over time with water. It's slow, but it happens. So you look at landfill leachate, and it's impossibly estrogenic because of BPA contamination, up to parts per 100. I mean, it's just, nothing can live in that. And so that's where you have a problem with the monomer. You can make plastics from, for example, polylactic acid initially from corn, but that's a fairly brittle plastic, and you end up adding a lot of additives, and it turns out that when you extract it, it lights up endocrine disruption assays like crazy. So we have to deal with, the number one thing you've got to do is test. Every chemical that goes into a plastic, it has to be tested. If it's got low dose adverse effect, it's out. And many of them do, unfortunately.
I think I just would like to add one quick comment to recycle plastics. Plastics also have this property that they can act as a sink for chemicals, and depending on what you have stored in the plastic or how you store it during your processing, the way it's recycled and so on, it can lead to actually increasing chemical contamination from various sources. So that's just a material inherent property of plastics. So it's a bit more tricky, this business of recycling plastics.
Jane, can I just add one tiny point?
Please.
I mean, there is around the world an effort to collect plastics off beaches or recycle plastics and make building materials from them. So you have this in very poor locations, the Philippines and Indonesia, going on, where people will get plastic bottles and stuff them with plastics and use those as pretty good insulating materials for building walls with basically mud. Problem is that when you heat those up, the additives are coming out, and so you're literally putting people in. I mean, one can assume with very high confidence, I should say, that the additives coming out. So you're putting people in their homes where the walls are emitting for a very long time these compounds with low dose adverse effects. You have people building concrete block-sized plastic blocks to put up cheap housing for poor people. These are disastrous trajectories when there are endocrine disruptors in the plastics.
Yeah, thanks Terry for bringing that up. It's a form of what I call neocolonialism. Yeah. Okay, I'd like to take one last question from Anna. Anna Watson, would you like to ask it? Unmute yourself.
Yes, if you can hear me, Jane.
Yes, sure.
Great, thank you, everybody. Really enjoyed the conversation so far. I just, you know, when we look at, you know, maybe colleagues of ours that work on climate change, you know, we see that there are global mechanisms there to address the climate emergency, such as setting things like a global carbon budget. Do you see that any possibility that, or any mechanism that we could use to reduce in a similar way our chemical burden that we're currently putting on the environment and ourselves?
It is actually very simple. You must do the appropriate tests. So if you if you test a chemical and it turns out to have low dose or low concentration adverse effects, you know you've got a problem. To date, virtually across the world, we have not done this testing. So if we can, there is a very clear pathway to success, and it involves the kind of testing that the European Union and its CSS is talking about doing. Please do it, because that is the way forward, the safe way forward. And I'll say again, I think the low dose adverse effects are 90+% of the problem. Sorry, Martin.
You know, just and then act on it. Do the testing and then act accordingly, because the implications will be huge. Yes.
Okay, so I thought that would be a much more complicated answer. So I think we have time for another question, again from Eva Kumar. I will just read it out in the chat. With the bans on use of many brominated flame retardants in force, will there be a shift to safer flame retardants? But again, the question remains how effective and safer those substitutes will be. That's a very good question, Eva. And I have a hunch Terry's going to say it depends on the testing.
Absolutely, it depends on the testing. So Arlene Bloom is a long-time friend of mine. And Arlene, of course, moved heaven and earth to get rid of TB117, the technical bulletin from the early 80s or late 70s, so that required you add flame retardants to furniture, to couches and things like that, so that you could get an 11-second delay on ignition. She overturned the technical bulletin, thank God. I don't think the question is, what do flame retardants really do for you? And I've seen videos that make it look like they're very successful, and I've heard researchers who are leaders in the field saying that they're not that successful. But for sure, if they're going to be flame retardants, they shouldn't have low dose adverse effects.
Okay. Any last words from Terry or Martin? If not,
well, I'd like to thank you for putting this on Jane, and for the incredible work you're doing at the Food Packaging Forum.
Well, thank you, Terry. Thank you for your great work, and thank you also, Martin, and thanks to all of you for joining us today and for your questions and comments. I would like to share my screen just to close us off. So we already heard it. Pete Myers will be speaking in our next session in this webinar series on the 15th of April about endocrine disrupting chemicals. And Thomas Backhaus will be speaking about mixtures and how to tackle mixtures of chemicals in a regulatory context. So you can sign up for that. I'll pop the link in the chat in a second. And then I would also just like to ask you to save the date and have a look at our upcoming Fpf workshop, which will be held in October. We're playing it safe again this year. We will do this again as a virtual event. Hopefully we can come together in person again in 2022, fingers crossed. But for this year, it's going to be a virtual event on the 6th, 7th, and 8th of October. And we're putting the program together, and it would be wonderful to see all of you there. So please have a look for further details. And with that, I would very much like to thank everyone for joining us today. We will publish this webinar on the FPF website and make it available for future reference. And we're always interested in a dialogue with you. So reach out to us on LinkedIn, Twitter, we're on Facebook now. Send us an email, give us a phone call, and let's talk about this issue further. Great, wonderful. Have a great day. Thank you, everyone.